Okay, good afternoon everyone. Naririnig ako ng maayos? Clear? Okay. So for this afternoon, our topic is all about the gas laws. So basically, our objectives for this afternoon is, first one is the the application and the definition of the three gas laws, mainly the Boyle's law, Gay-Lussac's, and Charles law. So that's our first objective. Then the second one is what is the application? Okay, so we have to determine the application of the three gas laws na i-discuss natin for today. And the third one is to solve, of course, solve problems involving the three gas laws. Okay? So first one, of course, bago tayo mag-start kay first gas law, so basically, yung pag-uusapan natin, since gas laws yan, so we're talking about the gases. Okay? So we all know that gases among the three states of matter, gases is kung i-compare natin in terms of their composition is they are very distant in terms of their composition of molecules. So meaning to say all of the molecules in the gases are very excited. Paano sila naging excited? Ba? Maraming paraan or although hindi natin sila na-observe using our naked eye kasi hindi naman talaga natin nakikita ang gases, but still na-feel natin, 'di ba? Kapag ginanon lang natin yung kamay natin, 'di ba? Feel natin yung mga gases na 'yan. Okay, so we all know that gases are hindi lang naman isa, no? In the air or in the atmosphere, we have different gases na nagsasama-sama. So we have oxygen, nitrogen, okay, carbon dioxide, okay, and other gases. Okay? Now basically, the first gas law that we will discuss is the Boyle's law. Familiar with the Boyle's law? Familiar with that? Boyle's law of gas. Okay, so the proponent of this Boyle's law is none other than Robert Boyle. Okay, so we have the Boyle's law, which is kay Robert Boyle. Robert Boyle. Okay. So in the Boyle's law, according to Robert Boyle's experiment, okay, so ang dinescribe niya, he described that the relationship between the pressure wait lang, the pressure and volume of the gases. Okay? So actually, meron tayong mga quantities na tinitignan for the gases, for characteristics of the gases. Kasi di ba ang gases, pwede natin siyang i-explain through theoretically, like the states of matter and its composition. Pwede rin siya experimentally using the series of experiment. Okay? And pwede rin natin siyang i-define into mathematical. Like, ito yung ginagamit natin. Okay, so in mathematical explanation of gases, we are looking for different quantities. Number one, of course, is the pressure. Diba? We all know that gases contains pressure, kaya nga tayo may air pressure eh. Okay, another one is the volume. Although hindi natin nakikita yung gases, pero meron silang sariling volume. Meron silang sariling volume. Yes, nag-occupy sila ng volume kung ano yung nandun sa container. So, ino-occupy niya yung volume. Then, as well as the temperature. Okay? So, uunahin muna pala natin. Wait lang. Lagay muna natin, before tayo kay Boyle's law, ilagay muna natin yung mga quantities na given kay gas laws. So, we have for gas laws, para lang dire-diretso tayo pagdi-discuss. So, meron tayong una is the pressure. Okay. So, yung pressure natin is, number one, pwede nating gamitin for units. Meron tayo ditong atmosphere. Meron tayong torr. This one is the units ha. Torr, meron tayong millimeters mercury, meron tayong pascals, meron tayong kilopascals, what else? PSI. Okay, or ano nga to? PSI, nakalimutan ko lang tong ano na to, pero wait lang. Sige, mamaya i-discuss ko na lang ulit. Okay, and as well as their values. Kasi magkakaiba yung values nito, yung mga constant values niyan in different unit. Okay, so mamaya i-explain ko yan. Then we have the volume. Okay, so volume is pwede siyang maging in milliliter or pwede rin naman in liters. So it depends. Okay. Next, number 3, of course, is the temperature. Okay, so in temperature naman, for temperature we have Kelvin. Or pwede rin naman na capital K lang. So mostly ang ginagamit natin or mas sanay tayo is in terms of degrees Celsius kasi yung ginagamit talaga natin. But when we are discussing or calculating for the gases or the gas laws, Kelvin dapat. In Kelvin yung temperature natin. Nga pala guys, ang nandito kasi, ang constant natin na gagamitin is in volume is in liters. Kasi meron tayong value na 22.4 liters. Okay, pero kahit alin dyan. So, hindi ko nare-record kung ano yung dapat maging sagot. So, basta magkaparehas lang tayo ng unit in milliliters. So, kung ang ginamit nyo is milliliters, then dapat milliliters lahat. Kung ang ginamit nyo is liters, then dapat liters lahat. Okay? So, next, for number 4, we have, of course, the, let's say, moles. Or this one is the amount of substance, right? Ito yung na-discuss lang natin last time. Amount of substance, which is in MOL. And then, meron din tayong number 5 for ideal gas. Ideal gas constant, which is yung R natin. Pero i-discuss ko na lang siya kapag tayo is nasa ideal gas law na. Okay? Or ako na lang i-reveal yung may pa-reveal. I-reveal yung kanyang value kapag ideal gas na tayo. Pero magfo-focus muna tayo dito sa tatlong ito. Okay? Ayan. So, yan basically lahat nung madidiscuss natin doon sa ating gas laws, sa pagtatalakay natin ng gas laws. Okay, so let's start with the first gas law, which is the Boyle's law, which is number 1 and 2 quantity, the pressure and the volume. Okay? Wait lang. Ayan, so nakita ko na. Ayan. So for pressure, discuss ko na lang muna din para meron na kayong copy. For equivalent pressures to ha. Okay. Equivalent pressures natin dito, ang ang constant or ang standard unit natin for pressure is in atmosphere. So for every 1 atmosphere, there is equivalent 760 millimeters mercury. Okay? So ginagamit lang natin to, of course, kapag meron tayong different units ng pressure. So we need to convert pressures, the units, para magkapare-parehas tayo and pwede tayo makapag-cancel out. Okay? So that is number 1, 760 millimeters mercury. Same with Thor, which is 760 Thor din. Okay? Next, for pascals naman, meron tayo ditong 101,325. So, meron tayo ditong 101,325. That is in pascals. In kilopascals naman, meron tayong i-convert lang naman natin siya into kilo. So magiging 101.325 yan. Okay, so we have 101.325 kPa. Okay. Next, for PSI or ano nga ba to? Pounds per inches squared o yon. So that is 14.695. Okay, so that is 14.695 PSI. So yan. Ayan yung commonly lang naman na ginagamit natin for pressures. Okay? So halimbawa lang na ang given natin is, let's say ang given natin in the problem is PSI and pascals. So mamimili na lang kayo sa dalawa since wala naman doon yung wala doon naman nakalagay doon na what is the pressure in the atmosphere kung halimbawang ganon. So mamili na lang kayo sa dalawa kung ano yung i-convert nyo, kung gagamitin nyo ba is pascals or PSI. If you want to use the PSI, therefore si pascals gagamitin nyo siya or i-convert nyo siya into PSI. Nakuha po. Okay? And pero ang pinaka-safe kasi dyan guys is both, since ang standard standard pressure natin is atmosphere, therefore gawin na lang natin siya into atmosphere. Nakuha? Pero kung halimbawa naman guys in the problem, we have two the same units in pressure. Let's say meron tayong parehas na millimeters mercury, so no need to convert that into atmosphere. Okay, use the millimeters mercury instead. Kasi yun na yung nandun nakalagay We have two same units in atmosphere or in pressure So gamitin nyo na lang yon. Okay, so magkakaroon lang tayo ng atmosphere if mayroong magkaiba na units for pressure. Okay, and then yung volume naman, it's either in ml or in liters. But in temperature, you must convert the degree Celsius or degree Fahrenheit in Kelvin. Nakuha po? Questions? How to convert degree Celsius into Kelvin? Kayla?
Mag-a-add lang po ng 272.
Okay, exactly. So we add lang natin yung degree Celsius into 273, then magkakaroon na tayo ng Kelvin. Okay? So let's proceed. Clear na tayo dito? Question so far? Wala? Okay, so let's proceed now to the Boyle's Law. Okay, so nabanggit ko na rin naman kanina that the proponent of the Boyle's Law is none other than Robert Boyle. And his experiment led to his definition about the relationship between the pressure and volume. Wherein, according to him, the relationship between the pressure and the volume is inversely proportional. Tama ba ako? Inversely proportional. What do we say? What do we mean by inversely proportional? Kapag sinabing inversely proportional, kapag ang quantity natin ng pressure is nag-increase, therefore the volume is decreasing. That is the inversely proportional relationship. On the other hand, kapag nag-decrease si pressure, aangat si volume. So that is the inversely proportional. Okay, so hindi sila compatible. All right? So that is the relationship between the pressure and the volume. Okay? So we have the equation or the formula to be used, which is ayan, ito. We have the P and V. Ayan yung dalawang yon. Now, hindi pa siya natatapos dito since meron tayong initial and final. We have the initial pressure, we have the final pressure, and as well as meron din tayong initial volume and final volume. So, meron tayo ditong P is equals to dalawa na yung PV natin. So, one is the initial, ilagay na lang natin siya as P1 or the initial, and for the final, we have P2. Okay? So this is the formula na gagamitin natin to calculate the Boyle's law. P1V1 is equals to P2V2. Okay? So halimbawa, ang hinahanap natin is V2, all you have to do is to derive the formula. So divide both sides by P2. Then, meron na tayong V2. Okay? Clear tayo dito? So let's have a sample problem. Yan. So we have our first sample problem, which is a gas sample contained in a cylinder equipped with a movable piston occupied 300 milliliters at a pressure of 2 atmosphere. What would be the final pressure if the volume were increased to 500 ml or milliliter at a constant temperature? So by the way, guys, in Boyle's law, palaging constant sa temperature. Kasi, kaya siya wala dito. Okay? So, constant ang temperature natin. So, let's write the givens. So, we have V1, which is 300 milliliters. Then, we have the V2, which is yung 500 milliliters. So, masasabi natin, guys, na V2 yung 500 kasi we have the term here increase, di ba? If the volume were increased. So, meaning to say this one is the final volume. Then, we have the P1, which is 2 atmosphere. Then, we are looking for final temperature. So, using the formula, P1V1 is equals to P2V2. Divide both sides by, saan natin i-divide? Kim?
B2 po, sir.
Okay, so divide both sides by V2 since we need to isolate the P2. P2. Cancel. Then we have the formula P2 is equals to P1V1 over V2. Next, substitute lang natin. So we have the P1 which is 2 atmosphere multiplied by the V1 which is 300 ml all over the V2 which is 500 ml. So cancel na natin to. Then we have 300 times 2 is 600 divided by 500. What will be the final answer? Precious,
1.2 po.
1.2. 1.2 atmosphere. Okay. So 1.2 atmosphere, tignan natin yung konsepto natin ng pressure and volume. What is the relationship? So since the given volume here is increasing, 'di ba? Kung mapapansin niyo from 300 naging 500 siya, therefore the pressure must go down. Kasi yun yung relationship between them eh. Alright? So from 2 atmosphere, bumaba siya ng 1.2 atmosphere. So meaning to say that our answer is correct. Nakuha. Clear tayo dito? Alright. So next example. Okay. So we have a balloon that contains 1.5 liters of air at 1.00 atmosphere is taken underwater to a depth at which pressure is 3 atmosphere. Calculate the new volume of the balloon. Assume that the temperature remains constant. Okay, so who wants to give the givens? Givens lang. Nelgy.
Volume 1, yung first volume po is equals to 1.50 liters. Tapos yung P1 is equal atmosphere. P2 is equals to atmosphere.
Okay, so new volume or final volume yung hinahanap. Next. How about the formula? Yes, Kyla.
Isulat po muna yung B1 equals B2. And then, i-isolate po natin yung B2. I-divide po natin sa P2. Both sides. Cancel. Tapos, yun po, substitute. 1.50 liters multiply. Ay, ano ba? Tapos, 1 atmosphere po. Balik. Tapos po, 3 atmosphere. Yan po, ang sagot po ay 0.5
0.5.
liters.
Okay. 0.5 liters. Did you get the same answer? Okay, so our pressure here is going down. Going down, going up. Okay? So from 1 atmosphere, naging 3 atmospheres. Ibig sabihin, there is an increase in pressure. Therefore, the volume must decrease. So from 1.5 liters, naging 0.5 liters na lang siya. So our answer is correct. Okay? Clear tayo dito kay Boyle's Law. Questions? Wala? Okay. Another sample or proceed tayo kay Charles. Clear na tayo kay Boyles. Ganun lang naman yan. Kahit anong kuhain natin dyan ng variables, all you have to do is to divide both sides. Yun lang naman yan. Okay? Next. How about Charles' law? Okay? Charles' law. Okay, so who is the proponent of the Charles Law? Sino? Proponent of this is none other than Jacques Charles, wherein his experiment is nagled sa relationship between the Althea.
Temperature and volume po.
Okay, volume and temperature. Okay, so we have the relationship or describe the relationship between the volume and temperature. Okay, so what do you think is the relationship between them? Kung si Boyles, kung si Boyles is um, nag-inversely proportional, how about volume and temperature? Um, Sige, Kim,
Sir, directly proportional po.
directly proportional. Okay? So directly proportional daw according to Kim. Yes, correct that the relationship between them is proportional or directly proportional. So meaning to say, whenever there is an increase in volume, there is also an increase in temperature. So ano yung application natin dito? Sino nakakita na ng hot air balloon? 'Di ba? Alam naman natin yung nangyayari sa hot air balloon, right? O anong meron doon? 'Di ba once na mainitan yung ang tawag doon, yung mismong balloon, nagyayari na i-inflate siya, 'di ba? Eh 'di ba yung nagpapa-inflate sa kanya is the heat. Kasi pag nawala ng apoy 'yon, magde-deflate siya or babagsak mismo yung hot air balloon natin. So that is the application, one application of the Charles law, which is the volume and temperature. So maraming application pa ang pwedeng maibigay natin dito. For Boyle's law, how about Boyle's law? Ano yung mga application natin ng Boyle's law? For Boyle's law, 'di ba, sabi doon, nag yung isang object is lumiliit ng volume whenever there is an increase in pressure. Okay? One application diyan and one experiment or one activity na evident yung ganyang relationship is the syringe. Alam niyo yung syringe? Yung panturok. Pero tatanggalin yung karayom, syempre. Okay, yung walang karayom. And then, di ba, syempre yung syringe natin, may butas siya dun sa dulo. Okay? Kapag dun sa isang malaking syringe, naglagay tayo no, ng, let's say, ganito. Ito sa Boyle's Law to ha. Let's say, ganito yung syringe natin, yung its structure ng syringe natin. Tapos, nandito yung, abang tawag dito sa pantulak na yan. Basta may pantulak dyan. Okay? And then, halimbawa lang na naglagay tayo ng, what happened? Naglagay tayo ng balloon dyan sa loob. Okay? Kapag pinrest natin to pababa, okay, kapag pinrest natin yung pababa, what will happen to the balloon? Kapag wala pang takip to, yung nasa dulo, okay, kapag wala pang takip yan, of course, lahat ng air pressure niyan will go out. Lahat na lalabas dyan. Okay? Kasi meron siyang hole. So, walang mangyayari. But, kapag tinakpan natin to, okay, ibig sabihin, there is no way na makakalabas yung air pressure sa loob. So, meaning to say, if we hold down yung pantulak natin ng syringe doon sa sa syringe mismo, tendency niyan is to bumaba yung volume or yung itsura ng balloon natin sa loob is magsi-shrink. Bakit? Kasi tinutulak siya nung air sa loob. Okay? Try nyo, try nyo yun kung gusto nyo. Pero ayun yun. Ganun yung mangyayari. Kapag ka tinulak natin yan, parang yung maganit yung magiging yung mangyayari doon. And then, bakit siya gaganit? Kasi yung air pressure sa loob niyan is kumbaga nako-compact sila or nadidikdik sila sa loob. That's why yung balloon natin diyan is mag-shrink. Okay? Kasi yun yung magiging epekto niya eh. Yun yung magpapakita doon na evident si kapag ini-increase natin si pressure sa loob, so nag increase yung pressure sa loob, therefore the volume of the balloon is decreasing. Okay, so that is one application of the Boyle's law. Okay, so let's proceed again to the Charles law. So si Charles law is, what happened? Okay. So si Charles law, meron siyang formula na, so we have volume and temperature. So we have volume. Same din na meron tayong initial and final. So we have volume over temperature. Okay, so again, meron tayong final dito which is volume and temperature, the final. Okay? Paano naman tayo halimbawa, ang hinahanap natin is temperature 1 or yung initial temperature. So how will we do that? Of course, ang gagawin muna natin dyan is, yes Kim?
Sir, mag-cross multiplication po.
Okay, so gagawin muna nating linear yung equation natin. So magkakaroon tayo ng cross multiplication. So all you have to do is to multiply V1 to T2 and then multiply the V2 to T1. Since ang hinahanap natin is T1, therefore divide both sides by V2 para ma-isolate natin si T1. Okay? So let's have an example. Sabihin nyo guys, pag nabibilisan na, ayan. Wait lang, close ko yung Chrome. Okay, so let's have this one. Yan. Nakikita? Or palaking ko pang konti? Yan. So we have several balloons are inflated with the helium to a volume of 0.75 liters at 27 degrees Celsius. Degree yan na, degree Celsius. One of the balloons was found several hours later and temperature had dropped to 22 degrees Celsius. What would be the volume of the balloon when found if no helium has escaped? Okay, so in this Charles law, the constant here is the pressure. So kanina sa volume, constant ay dun sa Boyle's law, constant si temperature given si volume and pressure. So for Charles law, constant si pressure given si volume and temperature. Okay, so what are the givens? Givens muna. John Lloyd.
Sir, yung initial volume po natin, 0.75. Tapos po yung initial temperature is 27 degrees Celsius. Tapos po yung final temperature, 22 degrees Celsius po.
Okay. So convert na natin agad to kasi 'di ba ang ginagamit natin is Kelvin, right? Okay, so convert natin to kahit sila is parehas na degree Celsius, Kelvin pa rin tayo kasi that's the standard unit. Okay, so convert this into Kelvin. So paano po i-convert to into Kelvin? Plus 273 lang. So 27 plus 273 is, Darrell,
300 Kelvin po. Tapos
300.
sa dito po ay 295 Kelvin.
Okay. natin, tsaka tayo mag-proceed kay V2. Okay, so once to solve for V2, other person's hand, other Collab's hand, wala na ba? Aside from Precious, Althea, Kim, hmm. Sige, let's have Janine.
Sir, tanong ko lang kung
Hmm.
go-cross multiply po muna kasi di-divide
Yes,
both sides.
cross multiply muna.
Cross multiply po ang sagot is V1 times T2 is equal to V2 times T1. Ang sagot po ay V2
Divide both sides by
T1 po.
T1. So
Ang
the
sagot po
formula,
ay V2 is equal to V1 times T2 over T1.
okay. Correct.
Tapos substitute lang po yung value ng V1 which is 0.75 liter times 295K divide 300 Kelvin. Wait lang po. Sagot po is 221.25 divided by 300. 221.
Final answer na yon.
Hindi pa po.
Okay. Final answer na natin.
Divide 0.2 ano lang po ba? 2 decimal? 0.74 po.
0.74.
Opo.
0.74 liters. Okay, did you get the same answer? 0.74? Alright. So if, check natin kung tama. So if yung nandito natin, kung makikita natin dito sa ating temperature, our temperature is nag-increase or nag-decrease? Nag-decrease, tama? Okay, so nag-decrease si temperature from 300 to 295. So therefore, velocity volume volume must also decrease kasi yan yung relationship nila eh. So we have a proportional relationship between them. So from 0.75 naging 0.74 which is correct. So kasi ganun lang din naman eh. 'Di ba? Almost konti lang yung decrease ni temperature. Okay? So therefore, konti lang din yung made-decrease ni volume. But again, they are proportional. So they must both decrease. Okay? So another sample, then proceed tayo kay Gay-Lussac. Okay. So a weather balloon is filled into the volume of 150 liters on a day when the temperature is 10 degrees Celsius. If no gases escape, what would be the volume of the weather balloon after it rises to an altitude where the temperature is negative 8 degrees Celsius? So what are the givens? Gilbert.
Yung V1 po sir ay yung 150 dito.
150 liter.
Yung T1 po ay 10.0 degrees Celsius. Tapos yung T2 po ay -8 degrees Celsius.
Okay.
Nanap po yung
Okay, so ano yung temperature 1 natin in terms of Kelvin? Precious?
Magiging 283 Kelvin po.
283 Kelvin.
Tapos
T2?
yung dito po, 265 Kelvin po.
Okay. So, ang inanap natin again is V2. So, based on our temperature is decreasing or decreased. So, assuming that our volume from 150 liters dapat less than 152 kasi nag-decrease eh. Okay? So, what will be our answer? Ano? Kim, sige. Formula muna.
Sir, yung ano na po sir, B1 times T2 is equal to B2 times T1. Then, divide both side by B2 po. So, magiging T1
Divide
is
both
equal
sides by...
T1 po sir, sorry.
Okay.
So, magiging ano po, B2 is equal to B1 T2 over T1 po.
Okay.
So, substitute lang po, magiging 150 liters times 265 Kelvin over 283. Wait lang po sir. 150 times 265 divide 283 is equal to 140.46 liter po.
140.46 liters. Did you get the same answer? Okay. So, masasabi natin na tama or this one is correct because the volume decreases from 150 to 140.46. Okay? Questions? Madali lang, di ba? Very basic. Oo daw, sabi ni Althea. Sige, madali pala. Bigyan natin
It's a
ngayon ng...
prank po.
It's
It's a
a prank.
prank.
Okay, sige. Let's proceed. Okay na tayo dito. Proceed tayo kay Gay Lusaks. Okay, which is our last topic for this afternoon. Okay. So, the next gas law is Gay Lusaks. Okay, so Gay-Lussac's law, the proponent of this is Joseph, tama ba ako? Joseph Gay-Lussac. Okay? Wherein, in his experiment, he described the relationship between the pressure and temperature. Ay, temperature. Okay? Wherein, what do you think? Kyla.
Pressure is ano po, directly proportional to temperature.
Okay, correct. So the pressure is also proportional or they have the directly proportional to each other. Proportional. Okay? So meaning to say if the pressure goes up, the temperature also goes up. If the pressure goes down, temperature goes down. Same with the relationship between the volume and temperature. Nakuha? Okay. So, kung same lang din naman yung relationship nila, So we have same formula, but this time instead of using volume, pressure yung gagamitin natin. So we have P1 over T1 is equals to P2 over T2. Now this one is the Gay-Lussac's law. Okay? So what are scenarios or live scenarios na pwede nating i-apply si Gay-Lussac's using the pressure and the temperature? Aside from pressure cooker, 'di ba? Tama naman 'yan, 'di ba? Yung sa pressure cooker. Subukan yung buksan 'yon habang mainit. What will happen? Na-try nyo na ba 'yon? Na-try nyo na 'yon, guys? Collab. Yung halimbawa magpapakulo kayo ng baboy inside the pressure cooker and yung sumisirit na yung ano. 'Di ba natunog 'yon? Oh, try nyo buksan. What will what will happen? What will happen? 'Di ba parang bubulusok yun or puputok yun? Okay, because pressure cooker, meron siyang mechanism na walang lumalabas doon na init talaga. Actually, walang lumalabas doon. Or kung meron man, meron doon sa maliit na piraso na yun. Unlike doon sa iba nating mga container na pinaglalagyan, sisingaw talaga yung init. So meaning to say, konti lang yung pressure na mabubuo doon. Pero inside the pressure cooker, once na ininitan natin yan, so pataas ng pataas yung temperature na, therefore, the pressure also goes up. And when, um, kung kayo man ay naging crazy, okay, kung kayo naging crazy at binuksan nyo yun, sasabog yun sa inyo. Diba? Mapapasok kayo doon kasi mataas yung pressure niya sa loob. Okay, so that is one example of the Gay-Lussac's law. Okay. So, let's have a sample problem for this one. Okay, so we have a sample of a gas has a pressure of 100 torr and 27 degrees Celsius. Calculate the pressure if the temperature is changed to 127 degrees Celsius while the volume remains constant. So, in Gay-Lussac's law, given the pressure and temperature, the volume is constant. So what are the givens? Yes, Rojas.
Sa pressure 1 po, 100 torr. Tapos sa temperature 1 po ay 27 degrees Celsius. Tapos sa temperature 2 po ay 127 degrees Celsius.
Converted na into Kelvin. Ilan to?
$400 po.
Ilan?
400 po.
400?
Kelvin.
Okay. Okay, so the temperature one is for temperature 1, the answer is 300. Tama ba ako? 300. Okay, so we have 300 Kelvin. Then for
Sa
temperature 2,
T1 po ay 400 Kelvin po.
okay, 400 Kelvin. Next po, how about the final pressure? So once to solve for the final pressure, hmm. Ivan,
Sir, yung magiging formula po by na nag-cross multiply na po is P2 is equals to P1 and T2 over T1.
okay.
Wait
Correct.
lang po. Wait lang po. Tapos po, bali po ang magiging solution po is P2 is equals to, ayan pala. Sorry.
Kala ko
Ayan.
nagko-compute ka na eh.
Sir, wait lang.
Akala ko kasi nagko-compute kaya, kaya sinulat ko.
100 times 400 is 40,000
Divided
over
by
300 Kelvin. Ay, wala na po natin. Bali po, ang magiging sagot po ay 133.33.
133.33.
Tor.
Okay, 133.33 Tor. Same answer akong nakuha. Guys, collab. Same. Okay. So, nag-increase. If you are, kung na-observe nyo dito, yung temperature natin is nag-increase from 300 to 400. Therefore, our pressure must also increase kasi yun yung relationship nila eh. So, from 100 torr to 133.33, so nag-increase siya. So, therefore, the answer is correct. Okay? So, next, who wants to solve for this problem? Yung susunod. Sige, Precious. Kinabahan ah. Okay, Precious. Para sa'yo talaga to. A gas initially at STP is changed to 248 Kelvin. Calculate the final pressure of the gas. Natutuwa ako sa reaction mo. Okay, so we have STP here. STP stands for the standard temperature and pressure. So we will use the constant values for this one. So we have the standard temperature, 'di ba? Ang STP natin, ito yung mga value natin for STP. For temperature, of course, meron tayong 273 Kelvin. So that's the standard. And for the pressure, of course, meron tayong 1 atmosphere. So meron na tayo ditong givens. So this one is the standard pressure and temperature. Nagulantang si Precious ah. So what is that? Okay, game. So givens.
Bali yung given po, yung sa pressure 1 po is 1 atmosphere. Tapos yung temperature 1 po ay, ano po yun? 248.
Temperature 1 is
273 K po.
273 K.
Tapos yung T2 po ay 273 K po. Sa gitna.
273 din.
Ay! Sorry sir, 248 K po.
Okay, 248 K.
Ang hinahanap ay pressure 2. T1, T2. Right.
Okay, so precious is correct. So kasi 'di ba ang nakalagay dito is initially at STP. So meaning to say yung mga STPs natin dito is partial lang or initial givens natin. Then, meron tayo dito nakalagay na change to. Therefore, this one will be our final givens. Okay? So, ang hinahanap dito is P2. Okay? So, once to solve, P2. Okay. Sige, let's have Daryl.
Sir, ano po? Na, may formula na po ba? Ay, wala pa.
Wala pa po.
So, yung sa formula po ay cross multiplication magiging T1 times T2 equals T2 times T1. Tapos, divide both sides by T1 po. Tapos, substitute lang po yung given. Magiging A, ay, 1 atmosphere times 248 Kelvin over 273 Kelvin. Tapos, magiging 248 atmosphere times K. Ay, wala na pala. Yung final answer na po ay 0.91 atmosphere.
Okay, so the final answer here is 0.91 atmosphere or yung atmosphere natin or yung pressure natin must go down kasi yung temperature natin dito is nag-decrease. So from 273 to 248. So from 1 atmosphere dapat less than 1 atmosphere to. Okay, so we have 0.91 atmosphere. Alright, so ganun lang guys. Lagi nyo lang tatandaan yung standard temperature and pressure natin. Okay, actually meron din standard volume. Okay, which is 22.4 liters. So that will be our standard volume. Okay, so if ever man guys na ang 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 mga givens natin dito, 'di ba? Since wala naman tayo ditong nilagay na halimbawa, ang given dito is not the temperature but instead meron tayong naging given na pressure which is in different units. Okay, so ano yung gagamitin natin na unit? Ano yung gagamitin nating unit? Since naka-STP tayo dyan. Let's say ang nakalagay dito is 248 millimeters mercury, not temperature. So how will you do this? Given the STP. Iko-convert nyo po ba si STP natin na 1 atmosphere into millimeters mercury or you have to convert the millimeters mercury into atmosphere? Alin sa dalawa? Pwedeng maalin, 'di ba, kung tutuusin. Pero since meron tayo ditong nakalagay na STP or standard temperature and pressure, ang gagawin natin diyan is to convert that into atmosphere. Okay? Kasi yun yung standard unit natin eh. So, i-convert natin halimbawa si millimeters mercury into atmosphere. Okay? So, paano natin siya i-convert? Halimbawa lang. Okay, so given si 248 millimeters mercury, kasya ba? Wait nga lang. Dito na lang natin lagay. So given si 248 millimeters mercury, convert that into atmosphere. So we have 1 atmosphere dito. Kasi yun yung kapag ko-convertan natin. And 1 atmosphere is equivalent to 760 millimeters mercury. So over 760 millimeters mercury. Cancel natin to. So what will be the answer? 248 divided by 760. What will be the answer? Rose.
0.33 po.
Okay, so the answer is 0.33 atmosphere. So ito yung gagamitin natin for our final pressure. If ever man na ganun. Okay? So lagi tayong atmosphere magko-convert. Okay? Kapag lang meron tayong different units. Pero kapag meron tayong same units, katulad na sinabi ko kanina, yun tayo, mag-stick. Kung PSI yan, kung kilopascals man yan, kung same lang yan, ayun yung gagamitin natin. But kapag different, lagi tayong kay atmosphere pupunta. Kasi that's the standard. Okay? Question so far? Wala? Are you sure? Okay, so I will end the recordings now.